All right, this video starts chapter 2, where we're looking at solving equations. And I really like how the textbook introduces you to that. And we'll do some of the same too in this Scribblecast. So equations are basically any kind of statement where you have letters or variables and numbers in which you have one side that you're saying is the same as the other side. Even though they might have different letters and numbers and stuff, you're saying this side must equal this side. So here's some familiar ones: the point slope for a line, area of a rectangle, perimeter of a rectangle. Those are examples, I guess, of formulas, which are really equations. So this side must equal this side. And what we do with any kind of an equation is you can count up how many variables there are. So in this one, there's 1, 2 variables. These x's are the same. And so if you know one of those variables, I could plug a value in for x there and there, and I could solve for the other one. And the reason why I can solve is because it's an equation where this side is equal to this side. Okay. One distinction we need to make right off the bat is between an expression and an equation. An equation, like I said, is a statement where you have an equal sign. So there's an example of an equation there. Since there's no equal sign in that one, it must be an expression. With equations, we can solve them. So we can find out, in this case, we can find out x is equal to something. And whenever we're solving an equation, that's always what we're looking for. Y is equal to something. B is equal to something. Whereas in an expression, see there's no equal sign there? All we're doing is simplifying. So we're not coming up with a value for x. We're just changing how this expression looks. This one, for example, I could multiply the 3 through, multiply the -2 through, collect like terms. So 3x minus 2x is x, minus 15 and minus 14 would be about minus 29. So this expression here is the same as this expression there. So they're equivalent expressions, but notice at the end I'm not suddenly going x equals something. You can't do that with an expression. All you're doing is rewriting it as an equivalent expression. Whereas an equation, you're getting an x. Now, here's their definition, or one that I use. It's a statement that says the left side is equal to the right side. And when you're solving an equation, what you're looking for is a replacement for any variable that makes the statement true. Like, for example, this one here. What is a number that I could put in for x there, 3 times x, where whatever I get here is equal to 6? Of course, you're probably thinking the answer is 2, and that would be correct. That is the solution to that equation. So that's what we're looking for. And sometimes there's one solution, sometimes there's a number of different solutions. Sometimes we're asked to check to see if a number is a solution. We'll do that on the next page. But oftentimes we're given an equation and we're asked to solve. So what is x? So a solution, like I said before, is any number or something where you can put in an equation and it makes one side equal to the other side. So here's a question. Here's an equation, and the question is 3 a solution? Okay, well, we could find that out simply by substituting. What I like to do is I like to write the equation down again, 2x minus 5 equals 2, and then everywhere I see a variable, I put in a bracket. And then in a different color, you don't have to use different color, but in a different color I put whatever the x is. So x here is 3. Now I'll see if this side here is equal to 2. Okay, 2 times 3 is 6. Then take away 5. Is that equal to 2? So 6 take away 5 is 1. Is that equal to 2? No. Therefore, here's our fancy little symbol for therefore. Therefore, 3 is not a solution. And in this case here, all we're doing is trying to see if the number is a solution. We're not trying to actually solve it. We're just saying, is this a solution? Okay, here's a couple maybe that you can try. Determine, so here is the number that you want to try. So these are all numbers that you want to try. And see if this is a solution to this equation. If I put an 8 in there, I'm just going to sort of do a visual check. Is that true? Yeah, it's true. Put a 30 in there. Grab your calculators and see if, hit the sign button, then hit 30, see if it comes out to 0.5. That one's true as well. If your calculator didn't come out to 0.5, it's because you're in radian mode and you should be in degree mode for that question. Here's another one. Ooh, is 12 a solution? So 2/3 times 12, that's a 3, minus 2 equals 3. So is that true? 2/12, so 2 times 12 is 24, divided by 3 is 8. So 8 take away 2, is that equal to 3? No. So not equal, therefore 12 is not a solution, etc. And we could keep going with those. So when we're solving an equation, like this is just substituting numbers to see if they're a solution. If we actually don't know what the solution is to solve it, we have to use some principles. Sort of like I was saying back on this slide. To go from any one of these equations to the answer, there's a number of rules that you have to follow. And so in Math 75, we'll give you a couple, Math 85, a couple more, Math 95, a couple more. The first one that we'll look at is called the addition principle. And what it says is if you add something to one side or subtract something from one side, as long as you do it to the other side, you're even. You have an equivalent equation. And the reason why we use any of these principles is that I want to get x is equal to something. In other words, I don't want anything else here to be with the x. I want x by itself. So up here, here's an equal sign. So on this side here, I got this 5. And that's caused me troubles. I don't want that there. I just want an x. So I want to get rid of it. And the addition principle helps us do that. So I've got an add 5 here. If I want to get rid of that 5, what I can do is subtract 5. I guess that might be called the subtraction principle. I guess to get technical, you could say you're adding a negative 5. I typically just think of it as minus 5. Okay, and the principle says if you do it to that side, you got to do it to this side. Now on this side, 5 take away 5 comes out to nothing. So on the left side, I just have an x. On the other side, I have 7 take away 5, which is a positive 2. So 2 would be a solution to that equation. And you probably saw that right off the bat. Notice I've got this little teeter-totter here as a picture to illustrate this. And really what you're wanting to do is keep a balance. So if you subtract 5 on this side, subtract 5 on this side. If you times by 2 on this side, times by 2 on that side. Maybe I'm getting a little ahead of myself. That would be a different principle. Let's try a couple. So here's one. I've got t take away 3 equals 19. I want t on its side by itself. I have to lose the minus 3. So to lose a minus 3, I would do the opposite operation. So instead of minus, I'm going to add 3. But if I do it to this side, got to do it to that side. There's my solution. There's another one. I want to lose the positive 1/2, so I subtract a half. If I do it on this side, I have to do it on that side. When I subtract them, I come up with this, simplifying. There's my solution to that question. Here's just a couple more. Maybe try those. Hit pause and see how you do, and then press play and see if that's right. Okay, hopefully you've pressed play. Here are what I'd say the answers are. Hopefully you got the same thing. So in this little scribblecast, we've looked at what an equation is, what a solution to an equation is, and we started with our very first rule to solve an equation called the addition. I guess you could call it the subtraction principle as well. Okay, try some questions in your book.